So let's talk about what is power first. So far we're talking about energy. So power, by definition, is either rate of work done, all right, or some people call it rate of change of energy, which is okay because W here represents either work done or change in energy, because according to conservation, energy is interchangeable. Okay, now, so the unit for power is actually like joule per second, or you can call it the SI unit, which is watt, W-A-T-T watt. Now, there's another formula for power which you may have seen before, so I show you how you get the formula. Since your work done here is force times distance, right, for constant force, so we can actually change the work done to force times distance, so you'll get this formula, right? Do you realize that the S divided by T is your speed? So that is how you also get another formula Fv, because S divided by T is also your velocity or your speed. So some people get confused. They say, when do I use this formula and when do I use this formula? Is there a difference? Now, by definition, it comes from here. So this is just another formula which you derive from here. So usually, we will use this formula to calculate average power. And usually, we will use this formula to calculate instantaneous power. Oops. Instantaneous power. So what is the difference between average power and instantaneous power? It is, for example, let's say you have a car. Okay, let's say you have a car which is traveling to the right, and the speed increases from 0 to a speed of 10 meters per second. So what will happen is the power of the car at this point and the power of the car at this point is different. So the power at this speed is called the instantaneous power. The power at this speed is called the instantaneous power. But if I were to find the average throughout the whole motion, that's called average power. Understand that? So if the speed increases uniformly with time, that means constant acceleration, then your average power will be half of your maximum power, because it's the highest or your maximum power right now. So if it increases uniformly with time, the speed here, then your average power is half of the maximum power. Understand that? But it's not always true. So usually, when people want to find instantaneous power, they will tell you the speed and they ask you to find the power at that speed. But if you want to use this formula, then you have to know the force and the speed at that instant. Which comes to our next question. This force here, is it an exerted force or a resultant force? So we need, it is exerted force. Because as we trace back the formula, remember it came from Fs, which is work done. And in work done, I mentioned specifically that this force, is it exerted or not? Exerted force. So this is exerted force at that time times the speed at that time. That is called instantaneous power. Okay? And you should also realize something. If you are going to use this formula P equals to Fv to calculate the power, you have to remember that the F and the V must be in the same direction. Just as how in work done, the force and the distance moved must be in the same direction. So for this formula P equals to Fv, the F and the V must be in the same direction. So how do we know whether they want instantaneous power? Look out for the term, find the power at this speed. So that means it's instantaneous power. Okay? Because it implies the speed keeps changing, you want to find the power at the instant. Average power is usually, they will give you a clue. They'll say, find the power over a period of a day or a period of 1 hour. So it's over a certain time period. So you have to find average over that time. Do you understand? Okay, so that's the clue. Okay, now some people also can use this formula to find average power, but there's a condition. Now imagine the force here and the velocity is constant throughout. Then wouldn't the average be the same as your instantaneous? Because it never changes. If it's always, force is always 10, velocity is always 2, for example, then your power is 20, but it's 20, 20, 20 throughout the whole time. So your average is also 20. You understand? So you can use it to find average power, but there's a condition. It can also be used to find average power if F and V are constant. Do you understand? Okay, so I want you to know what is the difference between the two. Now, in addition, if you want to find the average power, which is this formula here, what does the W represent? Now, you can use work done, or remember, it also represents change in energy. So the easiest way to find average power is to find the energy in the beginning, energy at the end, and we subtract to get this. That means you find the difference between your initial and final energy. This is your W. Not your final, not your initial, but the difference in your energy. Over the time taken for it to change. That's it. So if you have a graph of energy versus time, okay, which is energy versus time here, you can see energy versus time, then since power is rate of change of energy, so it is the gradient of the graph. You understand? So you want to find the gradient of a curve, draw a tangent first and then find the gradient. That is called instantaneous power. Understand? Alright? And since you know that the formula for power is your energy or change in energy divided by time. So the energy change is also power times time. So if you have a graph of power times time, or power versus time, you can actually use the area under the graph to find the energy change as well. Alright, that's also applicable. The next one is efficiency. So what is efficiency? Is how efficient you are converting your energy input to energy output. Or you can use power. You know why? Because if both sides, that means on top, I divided by time, I get power output. At the bottom, I also divide by time, I get power input right now. So it's applicable. So you can use either energy output over energy input or power output or power input. Now, multiplying by 100 is optional. Sometimes they will express efficiency in terms of percent, that means times 100. But if you don't, times 100 is also okay. That means you are stating your efficiency in terms of fraction. So what is the highest efficiency in terms of percentage? 100%. So what is the highest efficiency in terms of fraction? 1. Understand that? Now, can your energy output or your power output here, can it be bigger than your energy input or power input? Can it ever be bigger? You can't. There's no such thing as more than 100% efficient. Like for example, if whatever you eat and whatever turns to shit, right, it's only maximum 100%, right? You cannot shit more than you eat, can you? You can't, right? So that's the idea. Okay, so if you find your efficiency more than 100%, something is wrong. Okay?